Today we'll be talking about gas law, and we have different types of gas law. The first law is Boyle's law. The second law is Charles' law. We have Graham's law of diffusion. So before I continue, let's talk about the first two. Boyle's law states that the volume of a given mass of gas is inversely proportional to its pressure, provided temperature is constant. So Boyle's law states that the volume of a given mass of gas is inversely proportional to its pressure, provided temperature is constant. What does this mean? We have three major things that has been stated here that we must put into consideration. We have our volume, we have our pressure, and our temperature. So the law states that the volume of a given mass of gas is inversely proportional to its pressure, provided our temperature is constant. We should put at the back of our mind that the temperature must always be constant. So we are concerned more of pressure and volume. And as we go, we need to generate a formula that is related to this Boyle's law. As we can see, we say Boyle's law is inversely proportional. So we need to derive this law. You know, I said the volume. He said the volume of a given mass of gas is inversely. This is sign for inversely proportional to our pressure. So I will remove this proportionality constant by introducing a K. And that K will come in like this, and I'll cross multiply so that I can make my K a subject of formula. So when I cross multiply, what I will have is K is equals to P times V. That is PV. So for me to generate this formula, I will have P1 V1 is equals to P2 V2. And for you to actually know this formula easily without you cramming, you can see that nothing like temperature is appearing in this formula. That is why we say our temperature is constant. Then I have to let you know the meaning of all these variables, because you can't just cram them. You must know the meaning of all this. This P1 means initial pressure. This is my initial pressure. And my initial pressure is always expressed as millimeter mercury. That's the unit, millimeter mercury, or you can see it as torr in some textbooks. When you see either of these, it also means they are talking about what? Pressure. Initial means the first pressure. Then I also have P2, which is my final pressure. Also has the same unit as millimeter mercury or torr. Then I have my V1. My V1 also means initial volume, which is expressed as centimeter cube or dm cube. So it depends on what you have to calculate. So you can have it in centimeter cube or dm cube. When it converts from cm cube to dm cube, it means you are dividing your answer by 1000, because 1000 cm cube is equals to 1 dm cube. So you can either express it as centimeter cube or dm cube. While my V2 is my final volume. So that is the meaning of this equation. So Boyle's law is P1 V1 is equals to P2 V2, which says that the volume of a given mass of gas is inversely proportional to its pressure, provided my temperature is constant. I hope you get the point. Now we'll go to Charles' law. So Charles' law is a little bit different from Boyle's law, because Charles' law states that the volume of a given mass of gas this time around is directly proportional to temperature. I think we can see the difference to temperature, and this time around our pressure is now constant. So we have our volume directly proportional to temperature and our pressure is constant, unlike Boyle's law that our volume is inversely proportional to pressure and our temperature is constant. But for Charles' law, the reverse is the case. So how do we generate the formula for Charles' law? I will say V, since I said it is directly proportional, this is the meaning of directly proportional. I will not put 1 over this time. It will just be straight to my temperature. That is why it is directly proportional. So how will I generate my formula? I will remove this proportionality constant and input my K, which is V is equals to KT. I hope you are following. So I will make my K the subject of formula, just the way I make my K the subject of formula for Boyle's law. So how will I do that? I will divide through by T, divide both equations by T. And when I divide both equations by T, I will have K is equals to V over T, which means V1 over T1 is equals to V2 over V2, T2. Can you see that it's very simple? Then I will also define all these parameters. What is my V1? Just like we have our V1 in Boyle's law, the same thing we have for our Charles' law. So V1 is still initial volume, expressed as CMQ or what? DMQ. And I also have my V2 as what? Final volume. So they have the same unit. And I have my T1 to be what? Initial temperature. Temperature here is always expressed as Kelvin. I will later teach us how to convert from degrees Celsius to Kelvin, because we make use of Kelvin for temperature. That's the standard measurement for temperature. So my T2 is my final temperature. So how do I convert from degrees Celsius to Kelvin? Degrees Celsius, if I have a degree Celsius, let's say for example, I was given 12 degrees Celsius. How do I convert from 12 degrees Celsius to Kelvin? All what I need to do is just to add 273 to my original value that they gave to me. So if I add 273 to 12, what will I get? I will have 285 Kelvin. So I have converted straight like that to Kelvin. If I am given minus 10 degrees Celsius, just still add your 273 to your 10 degrees Celsius. What do we have? We have 273 minus 10. That will give me what? 263 Kelvin. I hope you understand how to convert from degrees Celsius to Kelvin, because you can never use your Celsius in any calculation. It is not accepted. You must convert to Kelvin before you can proceed to your question that you are giving. I hope you understand. Thank you very much.